Okay, the next polynomial question has px is equal to x cubed plus ax plus b. It has x minus 5 as a factor, and when it's divided by x plus 5, remainder is negative 60. Okay, and then it asks us to find the values of a and b. So find a and b. Alright, so first thing we need to do is actually do the division, because the fact that x minus 5 is a factor means that when you divide it out there should be no remainder. So we need to do x minus 5 going into x cubed plus ax plus b. Okay, so first up we are going to multiply by x squared, and that will give us x cubed minus 5x squared. When you subtract out, you get 0 for the cubes, and then you get plus 5x squared because it's minus minus. Now you bring down the ax here. This time we're going to multiply by plus 5x. That gives us 5x squared for the first term and negative 25x for the second term. Now be careful here. When you subtract the x squareds, that's nice because they go. When you subtract the these two, you actually get a minus 20, or plus, because it's minus minus, a plus 25x. And now we need to bring down the remainder, which is the b that's left over. And when we divide through this time, or multiply through, we need to multiply by a plus 25. So that you get a plus 25x minus 5 outside of a plus 25. Now it looks pretty gnarly, but when you subtract, you get the x squareds, the x terms cancelling, and you get b plus, because it's minus minus, 5 outside of a plus 25. Now that looks messy because it looks like we've got a remainder. However, what we know is that there is no remainder when they are divided, and therefore that tells us straight away that b plus 5a, I'm expanding now, plus 125 is equal to 0. Because if there's no remainder, because it's a factor, then the remainder must be 0 when that's divided out. So we've got our first equation, and I'm imagining that this is going to need to be done by simultaneous equations. Now note that a plus 25, this factor up here, this constant term that's up in the quotient there, that's not necessarily that important, so we don't know what that is. However, we need to bring in our second piece of information, and the second piece of information is that when x plus 5 is divided out, we have a remainder. So that should give me a second equation relating b and a. So let's do that. X plus 5 now is divided out from the same thing, x cubed plus ax plus b. And again, we're multiplying by x squared the first time, and we get x cubed plus 5x squared, and this time when we subtract we get negative 5x squared because there's no other x squared terms. We bring down the plus ax. This time we're multiplying by negative 5x, and that gives us minus 5x squared and minus 25x. And this time we get a plus 25x because it's a minus minus 25, so it's a plus 25. And then we bring down the plus b, and again we're going to multiply by this wacky term a plus 25 That gives us a plus 25x, and it gives us plus 5 outside of a plus 25. Now this time when you subtract those out, you should get a remainder, and you get b minus 5 outside of a plus 25. But that's not equal to 0 this time, because it's not because it's equal to a remainder, and that remainder is negative 60, and that means that b minus 5a minus 125 is equal to negative 60, and we now have two simultaneous equations that we can solve together there, number 1 and number 2. So combining them all up, we get, and I'm just literally going to do number 1 minus number 2. Doing number 1 minus number 2 gives me b minus b, which cancels. 5a minus minus 5a, which is 10a. I get 125 minus minus 125 is plus 250. And I get 0 minus minus 60, which is 60 on the right hand side. Cleaning that up, 10a equals minus 190, and then I get a equals negative 19. So that's my value for a. Now that I've found my value for a, I can sub back in to find b. I'm just going to sub that back into number 1 because it seems easier. And I've got b plus 5 lots of negative 19 plus 125 equals 0. 5 times negative 19, that's negative 95. So that is b plus 30 equals 0, and b equals negative 30. And there are your two values of a and b. And it's all done.